Hello friends, this video on transport in plants part 2 is brought to you by examfear.com. No more fear from exam. So we will start our discussion with diffusion. What is diffusion? It is a net movement of a substance from a region of higher concentration towards a region of lower concentration. A very common definition which we all know since our junior classes. So if you have two areas with different concentration, what do we mean by concentration? Suppose we are talking about any substance. Let us suppose we are talking about you have balls with you. Say you have around 50 balls. Okay. Now if there is one bag with 40 balls and there is another bag with only 10 balls. So when I talk about diffusion, it would mean that the balls will start moving from the bag A into the bag B until the number of balls in both the bags become the same. So it is something like the concept of heat. Heat flows from a body at a higher temperature to a body at a lower temperature. For example, when you keep a cup of hot coffee on table, what happens? If you observe the same coffee after 1 hour, you find that the coffee turns cold. That is because when you kept that hot coffee on the table, the temperature of the coffee was quite high when compared to the temperature of the surroundings. So heat started to flow from the coffee to the surroundings. Now over a period of time, heat reduced the temperature of the cup of coffee. So this happened until and unless the temperature of the coffee became equal to the temperature of the surroundings. And then you feel that the cup of coffee is cold because the temperature has actually decreased. Right? So the diffusion is also a very similar concept where objects or subparticles move from a region of high concentration towards a region of low concentration. For example, let us suppose this is a region where the concentration is very high and this is a region where the concentration of the particles is low. As you can see, the number of particles in this region is more and the number of particles in this region is less. So the concentration is high here and it is low here. So the concept of diffusion says that particles will start moving from region of high concentration towards region of low concentration. So now this substance which we talk about, so what kind of substance am I talking about? This substance can be an atom or a molecule or an ion or a gas. It can be anything. Similarly, this phenomenon of diffusion is seen very prominently in gases and liquids. It is seen less prominently, but it is seen in solids as well. When you talk about how rapid the process is, it is a slow process. It doesn't happen very fast. It happens at its own pace and the particles keep moving gradually. So it is a slow process. Now here, this movement will not keep on continuing for an indefinite period of time. This movement of the particle will happen only till the time the concentration of the two medium become the same. So this movement will continue till equilibrium is reached. Equilibrium means both the regions are at the same concentration now. So it will happen only up to that time, because you would have never seen that when you keep a hot cup of coffee over a table, even if you observe it after 1 day or after 2 days, you see that the temperature of the coffee is equal to the temperature of the surroundings. It doesn't turn into ice or something until and unless the surroundings temperature is too cold. So that is an exception case. But otherwise, this movement will continue only till the equilibrium is reached. So this is extremely important for gaseous movement within a plant. So in plant, we will see diffusion plays a very important role in the way how gases move inside a plant. Because just now I told that plants need quite a few gases very urgently. Like when you talk about carbon, hydrogen, oxygen, they need all of these gases. So this process helps in the movement of these gases from regions of high concentration towards region of low concentration within a plant. Now, what are the factors affecting diffusion? There are quite a few factors which affect diffusion. When I say which affect diffusion, I am trying to say the speed of diffusion or the rate of diffusion. Whether diffusion will happen very fast or it will happen very slow. When I say slow or fast, or when I talk about the rate of a diffusion, what I am trying to say is how fast or how slow the particles will move from region of high concentration towards region of low concentration. So let us see what are those factors. The first factor is obviously concentration gradient, because concentration gradient is something which makes diffusion happen. It is because of the difference in concentration that the process of diffusion take place. So now, more is the concentration gradient. When I say gradient, that means the difference in concentration. As I mentioned before also, let us suppose you have two regions. One is region 1, this is region 2. Now, this has high concentration. This has low concentration. So the movement will happen from 1 to 2. Now, if this concentration is very high and this concentration is very low, in that case, the difference in concentration is more. So more the difference in concentration, more will be the rate of diffusion. So faster will these particles start moving into region 2. So more is the concentration gradient, more is the rate of diffusion, because diffusion takes place from region of high to low concentration. So concentration gradient is one important factor which affects diffusion. And if there is no concentration gradient, there will be no diffusion. So that is a very simple logic. The next one is membrane permeability. Now whenever we are talking about a diffusion, we are talking about two different regions. Now there has to be a boundary to separate the two regions. Now we call that boundary as a membrane. The membrane which separates the two regions. If this is your region 1 and this is your region 2, this is the membrane which separates the two regions. So it also depends upon the permeability of the membrane. What do we mean by permeability? Permeability in the sense what all particles the membrane allows and what all particles the membrane doesn't allow. Now let us suppose here you have region 1 with high concentration of a particle. Say for example, let us suppose right now we are talking about a particle which is maybe a gas, a particular gas. Here the concentration is less. Now as per the concept of diffusion, the diffusion should take place in this direction. But now let us suppose the type of membrane which is present between the two regions, it doesn't allow this particular gas to pass through it. So in that case what will happen? The rate of diffusion will decrease. Right? So if the membrane is not permeable, that means if the membrane does not allow those particular gases to pass through it, so in that case, even though there is a difference in concentration, but still those particles cannot pass through the membrane, so diffusion cannot take place. So rate of diffusion will increase if the membrane is permeable to the substances. Permeable means the membrane allows those substances to pass through it, because if the membrane doesn't allow them, the rate of diffusion will prominently decrease. Next is temperature. Now the rate of diffusion increases with increase in temperature. Now what will happen if you increase the temperature of some particles? For example, when you boil water, what happens? You increase the temperature. So what happens when you increase the temperature? Whenever you increase the temperature, the particles gain kinetic energy. So the kinetic energy increases. Now when your kinetic energy increases, what is kinetic energy? The energy by virtue of its motion. So kinetic energy increases means motion increases, mobility increases. Mobility increases means diffusion increases. So it is something like this. Let us suppose you have region 1 and region 2. Region 1 is high concentration and region 2 is low concentration. Now let us suppose if you start heating, if you start increasing the temperature, what will happen? Each of these molecules will start moving even faster because their kinetic energy is increasing. So when they start moving faster, they will start moving faster from region 1 to region 2. So when they move faster, the rate of diffusion increases. So that is why we say with increase in temperature, the rate of diffusion also increases. Now what will happen with change in pressure? It is exactly the opposite to temperature. It will decrease with increase in pressure. Now why so? What happens when you increase pressure? Now forget about diffusion. Just take a very common example. Let us suppose there is a hall or a room which is fixed in size, and inside that hall you have these many people present. Now when you have these many people present, how many of them are present? Around 10 of them are present, right? Now, when these 10 people are present inside that room, we see that there are enough space between each of them. I mean, there are enough space that each of them can move. If this lady wants, she can move. This guy can also move. So they do have open spaces amongst themselves so that they can move. So the mobility is there. Now let us suppose if we try to increase the pressure. When we say we are increasing the pressure, what we are trying to say is, let us suppose if we increase the number of people in the same area. The area is not increased. The size of the room is still the same, but you have doubled the number of people present inside the room. Now when the number of people is increased, what happened? The space between the individual have reduced. Now they cannot move as freely as they were able to move before. Now let us suppose that again we are keeping the room constant and we still increase the number of people even more. Now what do you see? Now it seems quite congested. There is no space left between them so that they can move. So what happened? As you increased the pressure, the mobility or the ease to move reduced. So with increase in pressure, the mobility decreases. When mobility decreases, what happens? The rate of diffusion decreases, because when the particles are not moving enough, if they do not move, even if there is a concentration gradient, if the particles do not move much, the rate of diffusion will decrease. So that is why we say the rate of diffusion decreases with increase in pressure. Now another important factor is the nature of particle. Now what type of particle is actually undergoing diffusion? That is also very, very important. Now when I say nature of particle, I am actually talking about the size and mass of a particle. Now how do you think the mobility of a particle would depend on size and mass of the particle? It is a very logical thing to understand. For example, if there are two persons, one is a very fat person whose size is very high and mass is also very high. On the other hand, you have a little girl whose mass is very small, whose size is also small. Right? Now, if you ask both of them to participate in the same race, you have asked both of them to run. What would you see? You would see that this little girl runs quite faster, whereas the fat man takes a long time even to move from one point to another. So as the mass increases or as the size increases, mobility of the particle decreases. Therefore, we say that if the particle is very large, it has a very high mass or it has a very large size, the rate of diffusion will decrease. So the rate of diffusion has a lot to do with the mobility of the particles, and the mobility of the particles increases with increase in pressure, it decreases with increase in, it increases with increase in temperature, it decreases with increase in pressure, it decreases with increase in size and mass of the particle. So these were some of the factors, or some of the important factors rather, which affect the rate of diffusion. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.